So good afternoon guys, welcome to the Math 1500 workshop series. I am the instructor YG. So this workshop series is organized by the Math Help Center, and so it contains I believe 6 or 7 workshops during the term, and in each of the workshops it will cover one of the most important and difficult topic in calculus. So we will basically go through each topic by doing lots of practice, lots of examples here to get us familiar with these materials. So now let's get started. So my goal today is to go over question 1 up to question 22 in this first workshop. So it's basically about computing the limits, and in the next workshop I will go over the rest of the questions from 23 to these 6 questions in the continuity. And I think you can access this workshop from UM Learn or somewhere from the course coordinator Clifford. If you don't have it, just send an email to him. So now let's take a look at question 1. Actually, question 1 and question 2 are the same type. They are very easy. So when we try to determine the limits, the first thing that we need to do is to just plug in and see what we can get. If we get a defined value, then that is just the answer, very simple. So question 1 and question 2 will be of this type. So the first step is we just plug in, right, g equal to 4 into this expression, so that we have 2 times this 4 squared minus 4 divided by 4 plus 4. So we have 2 times 16, that is 32 minus 4, right, divided by 8. And that is 28 divided by 8, which is simplified to this 7 over 2. Okay, so very simple. So the answer is 7 over 2. And for the second question, do the same thing, just plug in 2 into the expression, so that we have this 2 times 2 squared plus 1 divided by 3 times 2 minus 2 square root, right? So 2 squared is 4, so 2 times 4, that is 8. So 8 plus 1, right? 8 plus 1 divided by 9 minus 2 square root, which is 9 divided by 7. Oh, sorry, this is 6. 6 minus 2, this is divided by 4 square root, which is 3 over 2. Okay. So question 1 and question 2 are just this straightforward plug-in type. Now let's move on to the question 3 and question 4, which is a little bit more complicated. It requires some work. So 3 and question 4. As I said, the first thing that we do for limit is to just plug in that value into the expression and see what we can get. If you plug in this I equal to 1 in the expression, then you see that I to the 4 is 1 to the 4 is 1, right? So this 1 minus 1 is 0. So you will have 0 on the top and 0 in the bottom. So this type you get is 0 over 0. for this type of limit, we will need to do something. That is to cancel the zero factor. What does it mean by canceling the zero factor? So the zero factor is a factor that is making the expression zero. As long as you cancel that out, you will be able to plug in after that. And this requires factorization. So we will need to factorize the expression on the top as well as the expression in the bottom. And the formula that we're using here is called the difference of square formula, which I'm writing it here. So I will be using this. A squared minus b squared equal to a plus b times a minus b to do the factorization. Now what I have on the top is I to the 4, which I will wield as I will see that as I squared bracket square minus 1 divided by I minus 1 limit and now I will use this difference of square formula to do the factorization. And now I square here, it's my a. Okay, this is my a, and this 1 can be viewed as I1 square. 1 here is my b. Okay, so I'm now doing this a plus b times a minus b. A plus b, which is equal to I squared plus 1 times I squared minus 1, right, divided by I minus 1. Okay. And the next step after that is that I continue to factor this expression I squared minus 1. Okay, I use this difference of square formula once again to factor out this I squared minus 1 into I plus 1 I minus 1 divided by I minus 1. Now after I factor this twice, I see that the both the top and the bottom have the same factor I minus 1. And this I minus 1 is the factor that is creating the zeros on the top as well as in the bottom. So it is the zero factor, right? So we can now cross it out, right? And I'm left with limit I goes to 1, I squared plus 1 times I plus 1 divided by 1. I have 1 left in the bottom. Now I no longer have zero factor after the cancellation, so that I can plug in I equal to 1 in the expression as before. So I will have this I squared, which is 1 squared plus 1 times 1 plus 1 divided by 1. And the answer is, what is the answer? It's 4, right? So you see that is a little bit more complicated than the previous 2 questions, but it's not that too much more complicated. Okay, so that is the second type of questions, factorization. Now let's continue to do question 4, which is also in this type. Equal to, we try to plug in as usual first to see what happens. If you plug in 3 into x, you will have 3 to the 3, which is 27, and 27 minus 27 is 0. So this thing goes to 0, this thing also goes to 0. So it's exactly the same type, 0 over 0, right? So that means you have the 0 factor in the top and in the bottom, so that you need to do the factorization. But for this question, I am not using the the difference of square formula. Instead, I'm using something that is similar, that is called the difference of cube formula. So difference of cube formula looks like this. It's a cube minus b cube equal to a minus b times a squared plus ab plus b squared. Okay, if you don't remember this, you can write down to remind yourself, because I think this is super useful in the long run. You will definitely need this in your future exams, I think. And now I have this x squared and this 27, which can be viewed as 3 squared, right? And now x minus 3. Now I apply the difference of cubes formula to write this as x minus 3, x squared plus 3 times x plus 3 squared divided by x minus 3. And now I see that on the top and in the bottom I have the same factor, x minus 3, which is the 0 factor, right? So that I can cancel them out as before. And I'm left with x squared plus 3x plus 3 squared divided by 1. Now I no longer have 0 factors, so I can plug in x equal to 3 in the expression. So I have 3 to the 2 plus 3 times 3 plus 3 squared divided by 1, right? And that is equal to 27. Okay, so the answer for the question 4 is 27. And see that both the third question and the fourth question requires the factorization before we can plug in, and that is what I will say the second type of limit that we need to know. Now let's take a look at the next question, question 5 and question 6. Question 5 first. So we see that the question 5 is a little bit more complicated than the previous two questions. So what we need to do here is to simplify the expression first. So you see that there is fractions inside the fraction, right? So we will need to turn this into one single fraction. And what we do is to eliminate the denominator on the top. I mean the denominator here. Right? So what we need to do is to multiply the top and the bottom together by the common denominator of the fractions on the top. So the fraction on the top has 3 and h, right? So we will need to multiply the top by 3h and also the bottom by 3h to get rid of that 3h on the top. Okay. So now we have that is 3h multiplies through the bracket and cancel with the denominators, so I have 3 left for the first term and h left for the second term, right? And in my bottom I just multiply this through, so I have, or I don't even need to. because I realized that now the top and the bottom, they both have h minus 3, so that I can cancel it out. If you haven't seen it, let me just reverse this subtraction, so I can write this as minus bracket of h minus 3. It's h minus 3 times 3h. Now I cancel this h minus 3, and I'm left with a negative 1 on the top and the 3h in the bottom. And I no longer have 0 factors, so I can just plug in, right? Plug in 3. And the final answer is negative 1 over 3 times 3, which is negative 1 over 9. Okay? So actually the same type of question, you will need to cancel the 0 factor. And before we cancel the 0 factor, we need to simplify the expression a little bit. So it's exactly the same thing as the previous 2 questions. Okay, then let's move on to the next one. Question 6 here, same thing. So if you plug in, you can get something nice, right? So we need to do some more work before we can plug in. And the first thing that we should do is to simplify the fraction to turn it into one single fraction. So I will need to find the common denominator of these 2 things, t and this t squared plus t. Realize that the t squared plus t can be written as t multiplied with t plus 1. So this already has the factor t multiplying with the another factor. So we don't have to actually do anything for this one. What we need is just to turn the first fraction into something that has the same denominator as the previous one does. So I will need to multiply this 1 over t with the t minus 1, t plus 1 on the top and t plus 1 in the bottom, right? So that it has the same denominator as the second fraction, so that I can combine them. Okay, so now the first fraction has been turned into t plus 1 divided by t times t plus 1, and I write my second fraction same way, t times t plus 1. Okay, and then they have the same denominator, so I combine them. So t plus 1 in the bottom, and the top I have t plus 1 minus 1. Okay, and then some computation tells us that the top is t, the bottom is t divided by this. And now I have the same factor t, which is the 0 factor, cancel it out, and I'm left with 1 over t plus 1. Now plug in, right? So I have 1 over 0 plus 1, which is equal to 1. Okay, so basically same as the fifth question. You will need to do some work to simplify the fraction before you can do the cancellation. So that is question 6. Now let's move on to the next type of question. This type of question it's kind of a one-sided limit, and it has some kind of absolute value inside it. So we will need to apply another strategy in order to deal with this type of questions. So when we have absolute value, we want to remove the bar absolute value. And before we do that, we need to determine what is inside the absolute value. I mean, the sign of the stuff inside the absolute value. Suppose that I have some stuff inside the absolute value, which is denoted by A. And when I remove it, I will need to follow this rule. Suppose the inside was originally negative, then when I remove it, the bars, I will need to place a negative sign in front of this stuff to turn that into positive. That is when A originally was less than 0. Okay? Otherwise, suppose the inside was originally positive or non-negative, then I can just remove the bars with no cost. So just remove the bars, right? So I'm talking about the stuff that was originally inside the absolute value. We need to consider the original sign of that stuff in order to do some adjustment when we remove the absolute value. So now let's check this stuff. The stuff here is 5 minus x, right? So the question is this 5 minus x positive or negative? We need to ask ourselves this question. That is the stuff A, right? And now how do we determine this? We will need to get help with the limit. The limit says x goes to 5 plus. What does that mean? If you draw a number line here, this is your 5, right? It means that the x is gonna approach the number 5 from the right side. So this is your point here that you start with. This is your x, okay? Imagine that you're taking this x and you go along this, this number line, and you're getting closer and closer to this 5 from the right side. So what I mean is that this x is always greater than or equal to 5, right? As it approaches the number 5. That means 5 minus x is always gonna be negative. Because if you use 5 to minus something greater than 5, you will get a negative output, right? So from here, we know that the 5 minus x is negative. And according to our discussion, if the inside was originally negative, then when we remove the bars, we will need to place a negative sign in front of that stuff to for the adjustment. Okay, so now the thing here is very clear. It's already very clear. We know that this stuff is negative, so we can just remove it with placing a negative sign. Okay, so 5 minus x. I'm not changing this. I am removing the bar, right? And I place negative sign in front of it. Okay. Now I can see that there is 5 minus x on the top and 5 minus x in the bottom. Cancel them out. I'm left with right now 1 divided by -1, which is already -1. So a very simple question, right? For this type of one-sided limit, and there is absolute value inside it, we will need to keep in mind the technique, how we can remove the absolute value and place a correct sign in front of it. And that it's depending on the stuff, the sign of the stuff inside the absolute value. And we can see the sign from the information from the limit notation. Okay, so that is question 7, absolute value. Question 8, same stuff, but a little bit more complicated. Okay. So we have absolute value, x minus 2, right? Now x minus 2 is my a here, is the stuff that is inside the two bars. We want to remove it, right? So we need to ask ourselves a question. It's the stuff that is x minus 2 positive or negative. Okay, draw the number line here. This is 2, right? And the sign, limit sign here says that x approaches 2 from the left side. That's 2 minus. Okay, so your point was here, x, and you're getting closer and closer to 2 from the left side. Right. You're dragging this point along this line and approaching this 2 from the left side. So you can see that x is always less than the number 2, right? Since it's on the left side, which means that x minus 2 is negative. Because you use something that is less than 2 to minus 2. Okay, once we know that is negative, according to the discussion there, we can remove the absolute value with a sign, a negative sign placed in front of it. So I can remove this and place a negative sign in front of it, right? There's x squared minus 4. Okay. And now this question has been, turned into the previous type of questions. That is the zero factor type. So now I can just make use of the difference of square formula to write this out. So this bottom here, this guy is x squared minus 2 squared, which is x plus 2 times x minus 2, according to the difference of square formula. So now I rewrite it. And see that there's the same factor on the top and the bottom. Get rid of them. And I'm left with x goes to 2 minus negative 1 over this x plus 2. And I plug in, okay, x equal to 2. That is negative 1 over 2 plus 2, which is equal to negative 1 over 4. Excuse me. Okay, that is question 7 and question 8. Absolute value stuff. So the thing is to remove the absolute value, and in the same time combine the same technique that we learned from the previous 2 questions. Okay. Now let's continue and see question 9. That is a new type of question. Okay, there's no absolute value and it's fraction, and there's nothing for us to cancel. We can make use of the difference of square formula, right? And instead we have a square root here. So what do we do? It won't be, that simple, right? Of course, we want to try to plug in, but you can imagine after plugging in, you will get something weird. So the straight plug-in type is the easiest. Probably you won't see that in the exam because it's just too easy. So now what do we do for this type? We get 0 over 0 after plugging in, right? So for this type, what we need is to multiply something that is called the conjugate. The conjugate. From the top, I have this. One plus something square root. 1 minus this. And the conjugate of this, it's just simply this stuff plus this stuff. That is called the conjugate of this expression. Whenever you have minus sign of 2 square root, you turn that sign into positive, and that is called the conjugate of that one. Whenever you have a plus sign, you turn that into minus sign, the other way around. So this is the conjugate of this guy here. Now, the technique is to multiply the top and the bottom by the conjugate. So I am multiplying this with 1 plus t plus 1 minus t, in the same time multiplying the bottom with 1 plus t plus 1 minus t. The reason that we need to multiply stuff on the top and the bottom in the same time is because we don't want to change the value of the fraction. If we just multiply it solely on the top or in the bottom, then it's another completely another different expression. So we make sure that when we do this thing, that applies on the top and in the bottom in the same time. Okay. Now, for the top, I can make use of my difference of square formula, because this is a minus b times a plus b, right? So it becomes a squared minus b squared. And that square will cancel with the square root. So I no longer have square root for that one, right? So it turns into a squared, which is this guy, bracket square, minus another guy, bracket square, all together over this t multiplied with bracket a plus b, which I'm not doing anything to it for now. Okay, and I continue. So it becomes, cancel the square root, just 1 plus t, 1 minus t. And do the computation. I have now open the bracket. The 1 gets cancelled, and t minus negative t, that's 2t, right? Divided by this. And now I can see that there is t on the top and in the bottom. Same factor, get rid of them. left with 2 divided by this 1 plus t, 1 minus t, right? And that is the zero factor. T has been cancelled. So I now can plug in. The expression in the bottom is still kind of ugly, but we don't care because the zero factor has been cancelled out. So I can plug in 0 into t. So I have 1 plus 0 plus 1 minus 0, which is 2 divided by 1 plus 1, that is 1. Right. Actually, also a simple question. And if we compare this question with the previous questions, what is new here is the technique to get that zero factor out. In the previous questions, we can just do something to the denominator or use the difference of square formula to get rid of the zero factor. But in question 9, there is also zero factor in here, but the previous methods are not enough to get rid of the zero factor. We need one more thing, that is to combine the, multiply the conjugate, right? And then we also use the difference of square formula to get that hidden zero factor out so that we can cancel them, and after that just straight plug in. So it's another technique for us to deal with zero factor type of limit. Okay, question 9, keep in mind that is conjugate. Now question 10 should be also conjugate. Question 10 here, I have this 5 minus square root of x, right? So the conjugate of this guy, it's it's 5 plus x. We just turn the sign in between into the opposite sign. So it's clear that what we need to do is to multiply the top and the bottom by the the same thing, conjugate plus. Okay. And now make use of the difference of square formula. This is a minus b. This is a plus b. Okay. Now continue the previous method. That is a squared minus b squared. So 5 squared minus square root of x squared. And from the bottom, 25, maybe a little bit factorization. For the bottom, I can factor out x, right? And I'm left with 25 minus x. Okay. Continue. I have 25 minus the square root of x is just x divided by x. 25 minus x. So now we can see there is 25 minus x on the top and the bottom for us to cancel. And I continue. So it becomes 1 over x, right? And I can plug in. So that is 1 over 25. Oh, actually I forgot to multiply with the other guy here. My bad. So I forgot to multiply this guy here. 5 plus this one. That was originally inside the expression. So let me do it. This is 5 plus. Okay, so I plug in. Now 25 multiplied with 5 plus, this is 25. So the answer is 1 over 250. It's a very common mistake to forget to multiply the other one. We need to also multiply this to the bottom. Okay, keep that in mind. Don't make the same mistake as I did here. That is question 10, using the conjugate. Okay, so should be a very common question for exams. Now let's move on to the 11, which is the most complicated of the conjugate type. Right? We not only have the square root on the top, but we also have the square root in the bottom. So you can imagine that you will need to do the conjugate twice. So the conjugate for the top is this guy plus 2. Right? Okay, so and the conjugate for the bottom, it's 3 minus x plus 1. On the top also 3 minus x plus 1. So we will need to multiply these two things in order to get rid of the stuff in the numerator as well as the denominator. Right? So it's doing the conjugate for twice. So now I can turn my top into just combining these two into this thing square minus this thing square, right? And don't forget to multiply with the other guide. That is this 3 minus x square root plus 1. That is my top. And my bottom, I'm gonna multiply this and this to get rid of the square root first. So I have now 3 minus x bracket square minus 1 square bracket multiply with the other guy, that is 6 minus x plus 2. Okay, here's the green thing, and this is the orange thing. Okay, now continue. Get rid of the square root by using the square. So x, 6 minus x, right, minus 4 multiply with 3 minus x square bracket plus 1. This is 3 minus x minus 1, 6 minus x plus 2. Okay, so that comes to this negative x plus 2 on the top, and in the bottom I have negative x plus 2. Same stuff, right? So I can cancel them out. So it's that difficult to see the hidden zero factor. Cancel them out. We have to multiply the conjugate twice and use the difference of square formula twice. But we finally arrived here. That is just 3 minus x inside the square root plus 1 divided by 6 minus x is plus 2. We don't have to do anything to it because the zero factor has been cancelled out. So just straight plug in 3 minus 2 plus 1, 6 minus 2 plus 2, that is 1 plus 1 divided by this 2 plus 2, which is 1 over 2. That's the final answer. Okay, now we see that the question 11 is very complicated, and it's a very ideal question for exam questions. So I would suggest going over this example and practice this over and over to make sure that you know how to deal with this conjugate, so that you're comfortable with using the conjugate twice, and also some kind of algebraic manipulation. Okay, so it's 11. That is the most difficult question we have seen so far here. Now let's take a look at the next type of questions. That is the question 12, question 13, and 14. Okay. 13 and 14 are relatively easier. Whenever we see trig function here, in most of the situations, we will need to make use of this limit that is already known. That is limit x goes to 0 sine of x divided by x equal to 1. This is a limit that is already known. Notice here, this symbol x does not only mean the variable x. It means it can be, anything. For example, I can replace this x by maybe by 2x or some other expression. And the result still applies, as long as the replacement here, it's also going to 0. Then this form is always gonna hold. So that is the idea how we make use of this limit. And also we can make use of the multiplication rule. That's the limit law. It says if the limits exist, then the limit of the product equal to the product of the limits. So we can interchange the limit sign in the multiplication. So let's see how we apply this one to these questions. Move this to somewhere else for now. Now for this one, you see that we have a sine of 3x instead of sine of x. So you can imagine that the original x in our formula has been replaced with the expression 3x. But x goes to 0 is equivalent to 3x goes to 0. So that does not make a difference. So we can just still use that form. But I need some adjustment here for the denominator, because the denominator is not 3x. So I will need to make up a 3x here in my denominator. Right? And since I can just make up a 3x, I will need to do the multiplication in the denominator, in the numerator, in order to cancel out this 3x I multiply with, and then place that x here. Now, this is still the original expression, right? I just multiply 3x on the top and in the bottom in the same time. I didn't do anything else. So this expression stays the same, right? I don't change the expression. However, by using the limit law, I can split this limit sign into the bracket. So now it becomes this times limit 3x divided by x. Okay? And these two limits both exist. The first one, it's 1 by the formula, right? The formula here tells you that this is 1. This of this form. So I have now this is equal to 1. And the other one I can cancel out the x. It's a 0 factor, so it's 3. Right? Now the final answer is 3. Okay? So the idea is basically just make use of the formula to construct that form and in the same time do some algebraic manipulation for the rest of the factors. Okay, so let's try the other one in the same way. We have this limit, x goes to 0, sine of 4x, right? So I will make up a 4x here because I want it to be in this form. And now I need to make up another 4x on the top to cancel with the original 4x and my 5x here. Okay, now I split the limit into the bracket. Sine 4x divided by 4x times limit x goes to 0, 4x divided by 5x. That is equal to 1 again times the other one. Get rid of this x. I have 4 over 5. So the answer is 4 over 5. That is very simple. Okay, so that is how we use this this limit. Now let's move on to the the next question. 14. We have tangent of x, right? That is relatively more difficult. Now the same idea, we want to make use of the limit, and then you're gonna construct the form sine of something divided by something as that thing goes to 0. So how do we do that? What is tangent of x? What is the relation between tangent of x and sine of x? Is that tangent of x is equal to sine of x divided by cos of x, right? So now I can start by replacing the tangent of x with the sine of x divided by cos of x, so that I can get closer to the desired form, right? And in the same time, I'm keeping my denominator, that is the x here. That is the denominator, right? And I kind of rearrange it. So this sine of x divided by x here, right? The This is 1 over cos of x. And now use the limit law to distribute this limit sign over the product. So sine x divided by x times another limit, x goes to 0, 1 over this cos of x. Okay. Now the first limit is 1 according to the formula, and the second limit we can just plug in. Cos 0, it's 1, so it's 1 over 1, which is equal to 1. Still very simple. We kind of turn the expression into the expression we want to always want to construct this sine x over x form in order to use the formula. Okay, so that is 14. Now let's try 15. So 15 here, we can use the previous method. Somebody may think that I can try sine of, 1 over x, right, divided by 1 over x to construct this form. However, the assumption says that the thing that is inside this sine of x and the thing in the bottom, this expression, has to go to 0. So you see in our previous example, the thing that inside the form, 2x, right, 3x, here, this 3x, or this 2x, or this x, they all go to 0, including this here, right? So the thing that, the stuff that is being applied always go to 0. But now, the expression inside that bracket, it's 1 over x. And our limit sign says that x goes to 0, which means 1 over x is going to infinity. So it's not going to 0, right? We know that 1 over x, it's not going to 0. So this technique will not help us to solve the question. So it's the wrong way to try. Just realize this. So what we do is now we make use of something called the squeeze theorem. That is the way to go. Whenever we see a limit that is very complicated, we can think of creating an upper bound and a lower bound for this expression, for this function, in which the lower bound and upper bound are going to the same limit. So they forces the thing in between to go to the same limit. That is like you have maybe a slice of beef in between, and you're kind of finding 2 pieces of bread, right? And then you kind of are creating a sandwich to squeeze the thing in between. So that is like that. So our idea is to create a upper bound for this limit, for this expression, and lower bound for this expression, in which these 2 bounds are going to the same limit, so that this expression is also going to the same limit. How do we do that? So we know that the trig function sine of something is bounded. So this expression, sine of 1 over x, it's always between positive 1 and negative 1, no matter how x changes, right? So that is the basic bound for this trig function. And I can multiply this inequality by x squared on both sides. So multiply through by x squared, right, by x squared. And when we're dealing with inequality, we have to be very careful about the direction of the inequality. We can't just simply multiply anything. If the thing that you're multiplying is positive, then it keeps the direction. Otherwise, it changed the direction. And now we know that since this x squared is greater than 0, this doesn't change the direction of the inequalities here. So now I can multiply this inequality with x squared. So x squared goes here, right? X squared also goes here, and x squared goes here. So what do I have right now? I have now sine of 1 over x multiplied with x squared is less than x squared and is greater than negative x squared. So I have created two bounds for the expression x squared sine of 1 over x. Right? If you don't see, I can place this one here so that you can see that clearly. Okay, x squared multiplied with sine 1 over x. Right? And these two bounds, they have the same limit. X approaches 0, this guy goes to 0, and this guy also goes to 0. Right? As x goes to 0. So this two bounds is like two pieces of bread. It's gonna squeeze the thing that is in between to create us a sandwich. So this squeeze theorem is also called the sandwich theorem. So now I can take the limit on both sides. So limit x goes to 0, negative of this, is less than limit x goes to 0, x squared, this, less than limit x goes to 0, x squared. Right? And this is 0, right? This is also 0. So it forces the expression in between to have the same limit, 0. Okay? Because it's like this thing is less than 0, less than or equal to 0, and in the same time greater than or equal to 0. So the only choice for this expression to be equal, it's 0. Okay? So that is how we make use of the squeeze theorem. So this is a proof type question. It's also a constructive proof. It's not like the previous questions, like using the conjugate or some factorization. It's like creating two bounds. So pay attention to this new type of question, squeeze theorem. Okay, 15. Now let's take a look at 16 here. It's also the squeeze theorem. So we have this expression. As I said, the trig function is bounded. Same for the sine x and the cos of x. We know that this is bounded by 1 and -1, right? And we can now multiply the expression on two sides. However, this expression now is x to the 3, right? Which is not always greater than 0. So it will change the direction of the inequality when x is less than 0. So we can't just simply multiply this. However, we can turn this into limit x goes to 0, x times limit x goes to 0, x squared times cos 1 over x by using the product rule. And we now focus on finding the limit of this one and the limit of this one. Okay. The second limit here has the square, so I can multiply the x squared on both sides as before. So it keeps the direction of the inequality. So I have x squared cos 1 over x less than x squared by multiplying x squared on both sides, multiplying through the inequality. And since this upper bound goes to 0 and lower bound goes to 0 as x goes to 0, right? By the squeeze theorem, squeeze capital we have limit x goes to 0, this cos 1 over x goes to 0. Right? So now we know that the second limit goes to 0, and because the first limit is also going to 0, right? So we have limit x goes to 0, x3 cos 1 over x. It's equal to product of two limits, which is this times the other one. The first one is obviously 0, while the second one is also 0 by our squeeze theorem. So the final answer is 0. Okay, so it's a little bit more complicated than the previous question. But still, you see that is also of this type, squeeze theorem. And squeeze theorem is basically about manipulating or constructing the inequality. And when we are dealing with inequality, we need to pay attention to the direction when we multiply things. Make sure that the thing you multiply is positive, so it keeps the direction. Otherwise, it changes the direction. That is a single thing that we should pay attention to. Okay, so question 16 and 15 are of the same type. How about 17? 17 will be of the same thing. Let's work it out. 17 here, right? Firstly, we know that this sine function is bounded between 1 and -1. Right? And the other factor here, which is x squared x minus 1 bracket square is something square, right? Something square is always greater than or equal to 0. So I can multiply this through without changing the direction. So I can have that, multiply this x minus 1 square here, multiply this x minus square 1 here, and here. So I have negative x minus 1 square less than or equal to x minus 1 square times this. Excuse me. Less than s minus 1 square. Okay. And now we have created the two bounds for the expression. And now we check the limit of these two bounds. Are they going to the same limit? As x goes to 1, this is going to 0. Right? You can just plug in 1 here. You see that goes to 0. This also goes to 0 as x goes to 1. So they have the same limit, right? And by the squeeze theorem, we have that the expression in the middle, in between, is also going to the same limit. Goes to 0. Okay, very simple. Okay, so that is how we use the squeeze theorem. So for the rest of the question from 18 to 22, we have these questions left. I don't think we have enough time to go over all of them, so I will skip some questions here. I think I will just go over question 20 and 21. And they're of the same type. And I will leave the rest of them for the next time. So let's take a look at this question. Firstly, if you plug in, you see that the denominator is going to 0. However, the top is not going to 0, right? Denominator going to 0, but the top is also going to 0 because that is negative 8. So that means we will need to do some factorization. Okay. So now the formula I'm using here, it's called the not the difference of cubes formula. Instead, it's the sum of cubes formula. So it's like that. A cubed plus b cubed, it's equal to a plus b times a squared minus ab plus b squared. Okay. And this, this x3 plus 8 here can be viewed as x3 plus 2 to the 3. Because 2 to the 3, it's equal to 8. Now I apply this formula to decompose this sum into a bracket, a product. That is x plus 2 times x squared minus 2x plus 2 squared. Okay? And after that, I am able to find out the 0 factor, which is x plus 2 on top. And in the bottom, I also have x plus 2, right? This square. So square, I can write this as 2x plus 2 multiplying together. And now cancel the 0 factor. And now I have this left. X goes to minus 2 minus x squared minus 2x plus 2 squared divided by x plus 2. Now I try to plug in, right? Try to plug in. I see that the denominator is going to 0. However, the top, it's not going to 0. The top is going to a defined number, that is 2 squared minus 2 times 2 plus 2 squared, negative 2 squared, that is going to 16. Okay, 16. So how do we do this when the top is going to a finite number, but the bottom is going to 0? So this type of limit, it's either positive infinity or negative infinity, or does not exist. We will go to the does not exist part in the future. That is about the two one-sided limits. So imagine now you have a fraction and the denominator is very, very, very small. So what happens if you have something like that? It will become a very, very large number when the denominator gets smaller and smaller. And one example of showing that is just this reciprocal function, y equal to 1 over x. Right? This is x, this is y. As you can see, when x gets very, very small, so imagine you have this point here, dragging this point toward this direction, so that the value of x becomes very, very small, right? That is in the denominator. And you see the y value gets very, very large, and it goes to positive infinity, right? Just going up. And in the same time, when this point is on this side, negative sign of x-axis, and you drag this point down so that the x is also getting closer and closer to the 0, right? So you can also see that the y value gets very, very large on the negative side. So it becomes negative infinity. So it can go up to positive infinity, and it can go down to negative infinity. That's the idea why when the denominator is small, the fraction is very large. That is the idea. Okay? So we know that is one of the three situations, positive infinity or negative infinity, or does not exist. Right? Now we want to figure out which infinity it is. Right? So we will need to figure out the sign of the denominator, right? From which side it's gonna go to 0, and that will determine the sign of this fraction. And for the top, it's always 16, so we don't need to worry about the top. It's about the sign of the denominator. So now we draw the number line here to help us. This is x plus 2, so we need a number negative 2 here. And the limit sign here tells us that x is approaching negative 2 from the left side. So this point is x here. It's going to here from the left side. Right? So what it tells us? It tells us that this x minus negative 2, which is just the same as x plus 2. This expression is going to be negative. X plus 2 can be written as x minus negative 2. X is less than the negative 2, and now you're using x to minus something greater than x. So the subtraction will be less than 0, right? So we see that this guy here is negative, and we know it's going to 0, so it's going to 0 from the negative sign, just like the this part here, right? This part here. This point is, the x-coordinate is approaching 0, but it's from the left side, from the negative sign approaching 0. So it results that the reciprocal, the y value, is going to negative infinity. So now we have that this is going to 16, right, over this going to 0 from the negative side, so it becomes negative, 0 negative. This is just a form, an expression that tells us that this is a very, very small negative number in the denominator. We are not actually dividing by 0. It's just a form, and so by our discussion is negative infinity. Okay, so that is question 20.